Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into query compilation in databases, a topic that's both fascinating and incredibly relevant to performance. The core issue? Disk speeds are outpacing query interpreters, creating a bottleneck. Right?
Absolutely. It's a classic case of hardware advancements outpacing software optimization. So, how are databases currently addressing this? Vectorization seems to be a common approach, but it's not a universal solution, is it?
That's right. Vectorization works wonders for OLAP-style queries, those big summary operations on compressed data. Think Apache Arrow and libraries like Data Fusion and Velox. They're making great strides there. But OLTP queries, with their index lookups and hash joins on sparse data, are a different beast entirely. Vectorization just doesn't scale as effectively.
I see. So for OLTP, the solution is often compiling queries to native code? That's a significant shift from interpretation.
Precisely. Compiling allows hard-coding parameters, keeping values in CPU registers for optimal speed. Databases like SQL Server, SingleStore, Redshift, and Oracle have embraced this approach with varying degrees of success. It also simplifies integrating external functions and procedural languages directly into the compiled code. A huge win!
But compiling queries isn't without its challenges, is it? The article mentions the trade-off between compile time and runtime.
Yeah, that's a huge hurdle. A query might only run once, so spending ages compiling it is pointless unless the runtime gains are substantial. Getting that balance right is incredibly difficult. Remember that Postgres JIT compiler incident? Yikes! It crashed the UK coronavirus dashboard.
Oh wow, that's a pretty dramatic example of the risks involved. So how are browsers handling this similar problem with JavaScript and WebAssembly?
Browsers use a tiered approach: interpreter, baseline compiler, and optimizing compiler. This creates a smoother trade-off curve, avoiding those performance cliffs. Ben Titzer's work on WebAssembly backends illustrates this beautifully. It's a really elegant solution.
Interesting. So the article suggests that databases could benefit from adopting a similar tiered approach, essentially adding a baseline compiler layer. Is that feasible?
That's the core argument. The author points out that while optimizing compilers are commoditized, LLVM crane lift, baseline compilers aren't, but they might be relatively easy to build. They even suggest some interesting shortcuts, like copy and patch techniques, which reuse interpreter implementations and cleverly manipulate linker relocations. It's pretty clever stuff.
Copy and patch sounds unconventional. Are there any other alternatives mentioned? Compiling directly to WebAssembly, perhaps?
Yes, that's another idea floated. Leveraging existing WebAssembly backends could save a lot of effort, however, there are drawbacks. Limited SIMD instructions, lack of control over runtime behavior, and potential performance bottlenecks due to WebAssembly's encoding. A mutable database project is exploring this path, though.
So it seems like there's no single silver bullet. The article also mentions generating interpreters from compilers and even generating compilers from interpreters. That sounds mind-bending.
It is. The idea is to leverage existing code to reduce development effort. InkFuse, for example, generates a vectorized interpreter from a compiler, and Weevil takes a different approach, working with any interpreter that can be compiled to WebAssembly. It's a fascinating space with many promising avenues for exploration. It's a really exciting time for database optimization.
Indeed. It seems the quest for optimal query compilation is an ongoing journey, with many innovative approaches being explored. Thanks for breaking down this complex topic for us.
My pleasure. And to our listeners, thanks for tuning in to Tech Bytes and News. We hope you found this discussion insightful. Have a great day, and we'll catch you next time.
Bye-bye.